Okay. Hello and welcome to week 13. We're going to be talking about recursion today. Recursion is a really fun topic, and I encourage you to think about it differently rather than just as a tool in computer science, because you can actually find recursion in the world all around you, just like I found on Instagram with Justin Timberlake and Jimmy Fallon. You can see that each of them has a coffee mug with the other's picture on the coffee mug, and then within the coffee mug you can see another picture of them. So it kind of keeps going and going, and just a fun little example of recursion. I encourage you to look in the world around you for other examples of recursion as well. This is another example of recursion, and I really like this because it's just this example of, so you have this really great sandwich, this amazing, delicious sandwich, and you take a bite and it's so good. You take another bite. And so really, if you think about recursion, it's really about each bite of that sandwich. You're breaking down each bite of that sandwich into a smaller sandwich, right? And so until you get down to the last bite of sandwich and you eat it, and then the sandwich is done. So you've pretty much eliminated the sandwich by eating it, but you could also think of it as a recursive activity as well. Another one of my favorite examples of recursion is the Cat in the Hat and the story that he had a spot on the carpet and was trying to clean the carpet, and so he needed some help. So he enlisted Cat A under his hat. Well, Cat A needed help, so he enlisted Cat B, and so on and so forth until they got to Cat Z, who actually came out and cleaned the spot, and then went back into the hat, until they all were back into their hats, back into the Cat in the Hat's hats. So you can go read that fun story. I think it's really fun, but it's a really great example of recursion as well, just in a simple Dr. Seuss book. Let's go ahead and dig in, though, and talk about some of the characteristics of recursion. And these are really important. I encourage you to write these down in your notebook. All recursive methods have these characteristics, okay? It's going to have one or more base cases, so it can have more than one base case, but this is the simplest case, and it's used to stop recursion. So every recursive call reduces the original problem, just like we talked about in that sandwich, right? We're reducing the original problem, bringing it increasingly closer to its base case until it becomes that base case. And so just like with our sandwich, we're taking a bite, we're making it a smaller sandwich, taking another bite, making it a smaller sandwich, taking another bite, making it a smaller sandwich, until it becomes the smallest little bite that we could take, and then we're down to our base case. So in general, to solve a problem using recursion, you're going to break it into subproblems. And that's one thing I want you to really think about, because a lot of people get scared when it comes to recursion, that they don't know what it means. It seems very complicated, and it's not really complicated at all. Just think about it as you're breaking down this big problem into subproblems so that it can be simplified and solved using smaller bites. Recursion is really great for solving some problems, okay? It's not great for solving all problems. It is great for solving some problems. And one of those problems is maybe you want to find a file under a directory that contains a particular word. And how would you solve that problem? Well, there's a lot of different ways to solve that problem. But recursion is actually an intuitive way to solve that problem, because it searches the files in the subdirectories recursively. So it goes through it and it looks for that particular word under each of those subdirectories, simplifying the problem into smaller problems as it goes. Okay. So what we're going to be doing in the next couple of videos is we're going to be computing a factorial using recursion. And so I want you to think about, and this is where you can actually stop the video and think about what the base case is and how does recursion simplify this problem. So at this point, I want you to kind of just stop the video and then write down this problem and kind of think about how we would solve this recursively. So I'm going to go ahead and stop the video here, and then I'll see you in the next video. But I encourage you to kind of work through this on your own first.